All right, we are on page 25. Okay, we're going to practice finding the slant asymptote. So let's take a look. So x cubed divided by x squared minus 9. First of all, let's kind of look and see if we need to find a slant asymptote. So the degree on the top, is it the same as the bottom? Is it bigger or is it smaller? Bigger, so that means, is there a horizontal asymptote? No, so that means there's a slant asymptote. To find the slant asymptote, you need to do long division. So x cubed, so plus 0 x squared plus 0x plus 0. And we're dividing by x squared minus 9. Okay, so you ask yourself, x squared times what is x cubed? X, yes. So this is x cubed minus 9x, subtract 9x. All right, can you do it one more time? So x squared goes into 9x. Does it go into 9x? No, so we just stop right there. You can't rewrite this in fraction form. So fraction form, just recall what you do is you take the quotient plus remainder over divisor. So this is the fraction form. Now, all you really need to find the slant asymptote is just the quotient. So the quotient is the slant asymptote. So the slant asymptote is y equals x. So slant asymptote is the quotient. Okay, slant asymptote is the quotient. Now the question is, what does slant asymptote actually mean? So I'm going to show you on Desmos what it actually looks like compared to the original graph. Okay. So this basically shows us that the slant asymptote does predict the graph's end behavior. You can do the same thing with horizontal asymptote too. So if the horizontal asymptote is 2, you graph it, then the two ends are going to 2 eventually. That's what it's saying. All right, let's try another one. You're going to find the slant asymptote. So find the slant asymptote by long division. This one you actually don't have to do long division because the divisor is actually a linear. If it's a linear polynomial, you can just do synthetic division. You can't do synthetic division when that is higher than a linear. All you're looking for is the quotient. All right, so let me just write this in fraction form first. So y equals to x squared minus 2x plus 1 plus 2 over x minus 1. So the slant asymptote part is only the quotient part. So y equals x squared minus 2x plus 1. Last thing we're going to do is bring everything together from the last chapter. You're going to analyze the graph. So everything you remember from last chapter comes together. It's so crazy. Yes, that's correct. So this part and behavior, let's just write the two ends. So x goes to infinity and x goes to negative infinity. And so that we practice, we're going to write the limit at the vertical asymptote as well. So you have the two ends. The two ends goes to infinity and negative infinity. And then we also want to write the behavior using limit at the vertical asymptote, just like what you practiced on the warm-up in last night's homework. All right, that's a lot of information, so go ahead and try it for a few minutes. You do want to graph it and look at it. You always want to factor the denominator just to double check to see if something cancels, because you don't want to accidentally have a hole and then you don't see the hole. That would be not a good idea. So make sure you double check, see if anything cancels. If it doesn't cancel, it's just a vertical asymptote. All right. Let's go over the answers. Let's start with, let me draw the graph first. All right. Let's start with Penny. Domain. You pick the points that you cannot have. But those points you pick is going to make the denominator undefined. So let's change it to not equal to. Not equal to what? 3 and, yeah, -2. Or if you wrote it in interval notation, it's -infinity to -2, -2 to 3, and then 3 to infinity. Okay, McKenna, range. Okay. Sherry, where is it discontinuous? Where, like on which x points, x values? Yes. So if it's asking you for continuity, like what type, then you say infinite. But this is discontinuous on, so it's just asking you where is it. Andy, increasing, decreasing. Where? Where is it decreasing? Huh? Decreasing has to be an interval. Oh man. Okay, I'm glad we reviewed. Okay, so it's decreasing everywhere. It's always decreasing, so basically the same parts as the domain. Caleb, symmetry. None. Oh no. Odd, even, or neither. All right. Oh no. Okay. Last chapter, come back. Okay. So even means it looks the same across the y-axis, right? So definitely not this one. Odd means you turn your calculator 180, it looks exactly the same. You can try it. Does it go through 0, 0? It's symmetry across the origin. So it could look similar, but it has to have symmetry across the origin. So it has to go through 0, 0. All right, so I'm pretty sure this does not go through 0, 0. So no symmetry, neither.
Okay, so none is non-resistant.
Yes.
Okay.
All right. Ashley, are you ready? Boundedness? Okay. Unbounded. Evan, local, absolute, extrema? Huh? You don't know? That's not a good answer. Guess. Huh? What? What about none? What did you say? Okay, there is no extrema. I'm like giving you guys all the answers. Okay, Iris, asymptotes. Okay, horizontal where? 0, and then vertical? Uh-huh. Okay, end behavior. Amelia, you want to try? Uh-huh. Good. And then when it goes to negative infinity? Okay, good. All right, Josh. One of the vast asymptotes. Let's say, what is this? Goes to -2. Limit as x goes to -2 from the negative side. What do you have? Yes, negative infinity. Let's try Trey. When x is going to -2 from the positive side. Yes. All right, next one. Limit as x goes to 3 from the negative side. Jennifer? And then units, limit as x goes to 3 from the positive side. Yes. Okay, good. Let's try one more, now that we have properly reviewed. Okay. Remember to put limit at vertical asymptote. All right, try it. This is a little tricky. So you need to trust yourself more than trusting the calculator. So what you have to do is kind of factor it. Okay, x plus 2, x minus 2. So looking at this function, you know there are 2 vertical asymptotes. If you're not seeing those 2 vertical asymptotes, like the effects of those vertical asymptotes, then you're not seeing the entire graph. So I think when you graphed it, you should only see one line, right? I think usually. So then you need to actually look at the equation and say, I should see 3 parts. If not, I'm not seeing 3 parts, something is wrong, especially since the degree on the top is bigger than the bottom, then I should definitely see a slant asymptote. So if you're not seeing that, you need to zoom out and actually see what's going on after x equals 4 and 2 and negative 2. So the graph, I think, looks something like this. I'm not sure exactly. Something like that. So you need to see this graph and then analyze this graph. Let's start with Mark. Domain. Did you just say equal to? Oh, okay, say that again.
Negative infinity to negative 2 to 2 and into infinity.
Okay. Good. I was a little scared. Blake, range.
All the numbers.
Sally, discontinuous on. Oof, increasing, decreasing. All right, Junior, give me the increasing. No. We have 2, we have maximum and minimum, so it's gonna stop at those places. So it's gonna increase until this point and then goes down, and then goes down again, and then goes down until this point and then goes up. You guys were able to find those points? Yeah? Okay, so increasing is until negative 3.545. Make sure you put a bracket because there is an actual point there. And then it's going to start again at 3.378 to infinity. Decreasing is from negative 3.545 to negative 2. Don't include negative 2 because there's an asymptote. And then negative 2 to 2. And then from 2 until 3.378 bracket. Alana, do you have the symmetry? Yes. So this one is none, no symmetry. It might look like it's odd, but if you try to do the check, it's not gonna work. Hold on, let me finish and then we'll take questions. Allison, boundedness? Yes, unbounded. Okay, extremus. Okay, this one's kind of long. Okay, local is at x equals, local max. Local max is at x equals negative 3.545. Local min is at x equals 3.378. Let me just give you the rest, or if actually, Aaron, do you have the slant asymptote? Oh, okay, that's okay. I'll give you guys the answer. So slant asymptote is at 2x. And then we have vertical asymptotes at x equals plus minus 2. Okay, and we don't have time to finish the other ones. I'll probably just finish it tomorrow.